but when you bond them, they make completely different properties. So that's what I mean when I say that they have different properties than what they were originally made of. Compounds, again, have a bond, so they are chemically combined, and mixtures, again, not chemically bonded. So the next slide I tried to compare compounds and mixtures. Compounds, we know, are made of more than one kind of material, so it has to be made of at least 2 different types of atoms. So compounds have to be 2 different types of atoms. Mixtures need to have 2 different substances as well. But the big difference is that compounds are bonded, mixtures are not bonded. Another big difference, compounds are separated by chemical means, mixtures are separated by a physical change or physical means. Compounds also have a definite composition. So what that means is if we had a glass of water, all of the molecules or all of the compounds of water in my glass will be H2O. All of them look identical. If I separated them by chemical means and I looked at all of those little components of H2O, they'd all look the same. But in a mixture, like for a salad, for example, the lettuce doesn't look like the tomato, and the tomato doesn't look like the crouton, and the crouton doesn't look like the cheese. So they all have a variable composition, okay? If we go to our next slide, I tried to give you 3 examples for you to determine if something was an element, a compound, or a mixture. So if you look at A, you can see that you have red circles, and they're really, really close or touching to 2 little yellow circles. So what do you think that would be? Do you think that would be a compound, an element, or a mixture? If you said compound, you are correct. So on A, I would say that that's a compound because I have 2 yellow circles, they're touching the red circles. So to me, it looks like there's a chemical bond there. So it's a really good example of a compound. Let's go to B. In B, I see nothing but little red circles. So it's just made of one type of atom or one type of little circle. So I would say on B, it would be an element. So on B, that's an element because it's made of one type of atom. I just see little red circles. So I think B is an easy one. On letter C, I see little red circles, but then I also see bigger yellow circles. And none of them are touching one another, but they're just kind of like randomly distributed throughout. So if I looked at that one, would I call it an element, compound, or mixture? If you say mixture on C, you are correct. So let's go back down to the next one. There's elements, compounds, and mixtures, and this is a really good one, again, on a microscopic scale. So we're going to practice looking at elements, compounds, and mixtures on a macroscopic scale a little bit later. Right now I want to focus on the microscopic scale, the stuff that you can't see, the stuff that, what we would look at for atoms. So I would like if you would try this one on your own, and then we're going to talk about this one in class. So this is the first question that I'm probably going to ask you on Monday when you come into class. So try that one on your own because I want to see what everybody would say. The next slide is a little graph, little chart that I made for you if you're having a hard time trying to figure out is it a pure substance or is it a mixture? Is it an element and a compound or is it a mixture? Or is it an element or a compound? So this is a really good flow chart to try to help you to get through that process. So you start off with matter. Everything is matter if it has mass and takes up space. So the first question I can ask, can this matter be separated by physical means? If it can be separated by physical means, it has to be a mixture. If it can't be separated by physical means, it's going to be a substance. Okay, but now I know that I have 2 types of substances. There's elements and there's compounds. So if you'll go through that flow chart, it goes through if you can determine if it will be an element or a compound. And then again, if you want to go through the side that says mixtures, you can determine if it's uniform in composition, it's going to be homogeneous. If it's not uniform in composition, it's going to be heterogeneous. So this is just something that I made to help you just in case you ever get confused. Let's go to the next one. So the next slide, the last slide, are just examples that I would want you to go through. So spaghetti sauce, do you think that would be an element, compound, or a mixture? I would say a mixture, because it's made of tomatoes, there may be garlic in there may be herbs in there, it's made of multiple things, but each of those things maintains its own properties, and I could physically separate out those different types of substances that are in that, or materials that are in the spaghetti sauce. Let's go to table sugar. Table sugar is a good one. So sugar, would that be an element, a compound, or a mixture?
I'll just keep that one until...
If you said compound, I would agree. It can't be an element because sugar is made of carbon, hydrogen, and oxygen. And it can't be a mixture because it can't physically separate out the carbon, hydrogen, and oxygen from sugar. So I would say it was a compound. Plus I know that the carbon, hydrogen, and oxygen that make up that sugar are chemically bonded together. And I know that if I sprinkled sugar out, they all look very similar. I want you to go now to, let's go to river water. On river water, element, compound, or mixture for river water, what do you think? If you said mixture, you're correct. So river water, tons of different little things that you could filter out through river water. So all of them would maintain their own properties. What about nitrogen? Nitrogen is the very last one on here. Would that be an element, compound, or a mixture? If you said element, you'd be correct. You know that nitrogen is on the periodic table of elements. It can't be broken down any smaller. So nitrogen is just made of all little atoms of nitrogen. So you know that one's an element. Okay. So that concludes our first little video, and if you have any questions, make sure that you write them down for me, and we'll go through them as a class on Monday before we do your chemical and physical changes lab. So don't forget that on Monday you have that lab, and you need to make sure that you wear appropriate dress for the lab, right? I'll see you guys on Monday. Bye!